Oh, all right, we'll start. But before we start, I have a few comments. One, if possible, can people doing inspections and construction send us pics of walls going up, concrete being poured, windows being installed? Because we're doing a guide for northern, a technical guide on northern housing. We're also trying to do a couple of smaller guides, and we have a bunch of picture placements, but I wouldn't mind replacing them with real pictures. If you send us pictures, we will give you credit for those pictures. And if you give a description of the community, we may, I'm not sure if I'll give the community name, but we'll just say in the First Nation, but definitely give credit to pictures being taken. That would be great. You can send them to info@FNNBOA or to Claude's email or to my email address, and we will receive them. Secondly, I have been getting a lot of survey responses. And again, I have a couple, I have one shirt for auctioning or for raffling off, Home on the Res. I think Gord's got one. We gave one to Gord for
I do have
his
one.
webinar presentation. They're unique logos, only can be found from an authorized distributor, which is FNNBOA. And I look forward to raffling off a shirt with more participants. So end of the day, if you can send your surveys in, and I'll do the raffle in the next few days and announce the winner at that time. For any questions, that'd be great. As I mentioned, we're looking at a new organization that will provide knowledge information sending out. And Gord, I need to sit down with you as well on the next probably couple of weeks. I'm thinking of coming to your place to Southampton. Are you there all the time or are you in Cambridge?
Well, I split my time, I would say.
You do, eh? Okay, so I will follow up with you on that. That's it for my announcements. Claude, you have anything else before we start?
No, we're good to go. It's Gord has the stage.
All right, here we go.
There we go. I will share my screen then. That's okay. Where did it go? There it is. So hopefully you're seeing a slide that says energy rating systems as a tool.
Yes. Yeah.
Great. So again, my name's Gord Cook, Building Knowledge Canada. We are an energy advising company, a building science company out of Cambridge, Ontario. We have roughly 20 employees, 25 employees doing energy modeling and performance testing on about 6,000 or 7,000 houses a year in the greater, I'll say greater Southern Ontario. We go anywhere from Windsor to Owen Sound over to Peterborough, those kinds of areas. We've done work obviously in the past. I shouldn't say obviously, but we've done work in the past for First Nations Group, Habitat for Humanity, plus I would say the mainstream builders in the Greater Toronto market. And this particular talk, I was asked to speak about, and I'll give you the agenda over the next hour, is a bit of an overview of the most widely used energy rating systems and energy modeling systems, a comparison of some of their key features, and then how they can be used to assess building performance. I thought I'd give you a bit of a sense of what they look like in different climate zones. Just kind of I've given you some extremes, frankly, of coast to coast to coast, and you'll see what that looks like. And then lastly, obviously throughout, think about what the impact would be on First Nations construction practices, I guess is where we'd start. And, I showed this slide last week, I guess, in terms of Passive House, but in Canada, there are roughly these energy programs, at least on the residential side. It would be different for community buildings, schools, and so on. But on the residential side, these are the various energy programs that are out there across the country. Some of them are province specific. The bottom right corner, for example, Nouveau Climat is a Quebec-based program. Built Green is in Alberta, primarily Alberta and BC. The Energy Star program is available across Canada. It's a Natural Resources Canada program, but it's primarily been successful in Ontario and so on. The one sort of bottom bottom middle HERS index is actually a US program, HERS index, Home Energy Rating System. It is delivered in Canada by one small provider, but generally speaking, it's a US-based program. So those are the various energy programs. I thought I'd go right back to the idea, and I know not all communities are using National Building Code, but just notionally understanding that in the National Building Code, there, from the energy perspective, which is 936 of the code, there are a number of compliance paths that are available. That is, on the left-hand side, you can meet performance requirements using what's called the prescriptive path. And it's a series of tables by climate zones on the left-hand side with some very limited choices and then some ideas of some trade-offs. So for example, it says thou shalt use R60 insulation pretty much across the country, R70 in northern. But if you don't want to use R60 and you want to use something less, then it would be okay to reduce the attic insulation, but increase the wall insulation, for example. So that's called prescriptive path. And it looks simple. A lot of builders use it because they just pick from the tables. In fact, I would say specifically in First Nations, we would say, and for many builders, but specifically in First Nations, and I'll describe why in a moment, I would suggest you should be using performance path. That is, if you wanted to meet National Building Code objectives or any energy objectives, I would suggest you use performance path. And performance path has you define a reference house, which is basically the same house you were going to build, same size, same geometry. And you use a software program. So can somebody go on mute there? Can you guys go on mute at Trinity there? Trinity Cardinal, can you go mute?
Yeah.
Can you guys put yourself on mute? Thank you. Oh, that's all right. Anyway, you would compare yourself to a reference home, compare your house you want to build. You use a software package, which I'll describe in a moment, and you energy model. And all you have to do is show that whatever you're proposing to build comes out as the same or less energy consumption than what the reference house. And the reason I say specifically for First Nations, one, modeling your houses is relatively simple. Very similar, I would say, geometry and so on. And more importantly, the prescriptive path was done based on a set of archetypes of houses, that include all kinds of, I would say weirder geometry, and therefore are very conservative in their approach, very conservative. And therefore, under performance path, you can dial in much better the energy performance of houses and get a better sense of where things are headed. And hopefully I can show you that as we go through this. In order to do the energy modeling, you have to use a compliant software. And this is just to say that there's a test that's done on the software. And down at the bottom left, there's right now 3 software packages that are available for energy modeling. One is HOT 2000, which is a Canadian government software. Another is Energy Plus that comes out of the United States historically. And then the Passive House program that comes out of Germany. So there are 3 compliant softwares. You can use any one of those and use that to model your buildings. Energy Plus is actually used on the commercial side as well. But you would model the house and do that compliant software. And so, as I say, I'll just go a little bit further. In terms of energy modeling software, they all give very similar comparative results. That is, they use essentially the same basic algorithms, but they use them in different ways, and the those algorithms is what's critical. And there's sort of 3, I would say, categories of software. First, on the left-hand side is HOT 2000, was developed way back in 1982 or earlier. It is owned and directed by the Canadian government. It's free. You have to be licensed in order to use it in most locations, but you don't have to be licensed necessarily, as long as you have credibility. I would say to learn the software is probably 3 days of reasonably good training would get you to understand what the software is about. You can fiddle with it on your own, but you'd probably want to take a training program. In the middle, there's a whole bunch of software programs out of the US. They're all private based. The US model is, here's the algorithms, you guys go make your own software. You see three of them there: Remrate, Ecotrope, Energy Gauge. Energy Gauge was developed in Florida, for example. Remrate is out of Denver, but they're national in scope, and they do have Canadian weather files, so that you could use it in Canada if they were qualified for code. And on the right-hand side is the German software. The key at the moment is in national building code, the US software is not compliant. Again, if you're not trying to apply the National Building Code, there's no problem with you using it. It is approved in Ontario. You can use it under the Ontario Building Code. And again, I'm not saying it's bad software. It's just they haven't gone through the rigmarole, I guess, of getting tested. And I'd like to use a phrase here that's a friend of ours in the industry, Michael Blasnick, who's undoubtedly the guru of energy modeling. He's the guy who makes the assessment as to whether energy efficiency programs actually work or not. He said this in a session. He said, all energy models are bad, but some are useful. That's kind of an interesting phrase, right? What he's really trying to say is none of these energy modeling softwares, they are theoretical. They are a series of algorithms. The algorithms are absolutely meet physics principles, but we don't know if that's the way a house is actually going to work on any given day in any given location. And what he's saying is if you modeled a house and then looked at the actual energy bills, it might be different, but that's okay. So they're not necessarily accurate or I would say perfect, but they are useful in what I'll call comparative mode. If you're trying to make a decision, should I put in triple glazed windows or double glazed windows and more insulation in the basement? Energy modeling software is very useful. You'll find it helpful, especially in new housing, but even in existing housing. The HOT 2000 software is used in existing housing to help people make decisions on what should I do next. So on the new Greener Homes program, for example, that the feds have announced, you would energy model a house and you would make a decision. Am I better to add insulation to the walls? Am I better to do windows? Am I better to change the furnace system? These are what we would call in comparative modes, and these software programs work. So I would encourage you to all get a familiarity, or perhaps say to you, get a relationship with an energy advisor. And there's about 700 licensed across the country. If you'd like to become one, they're encouraging that, of course, and there will be training available here shortly to get that done. But at the very least, and you can, there's an association called CASE, Canadian Association of Consulting Energy Advisors. I happen to be a member if you're interested in learning more about that and to get training to be an energy advisor. So either become one or have a relationship with one so that you could start to make use of these tools called energy modeling software. There we have it. In terms of the comparative mode of National Building Code, I just thought I'd give you a sense. The reference house and the proposed house, you basically take a house with the same geometry, the same service water heating source and size, the same HVAC configuration, similar quality of construction other than amounts of insulation, and you assume the same occupant loads. If there's going to be 6 people in your proposed house, there'd be 6 people in the reference house. And you do an energy model, and as long as you can show that your energy consumption is less than the energy consumption of the reference house, then you're good to go. And as I say, you would simply, the reference house is insulated to what's called the prescriptive levels of the code, the windows as per the prescriptive levels, the HVAC system as the prescriptive, and then you insulate the way you want to, do windows to your specs and so on. And I'll say again, it's worth a look because the style of housing that you're building typically will model quite nicely under the comparative path or the performance path. So we always recommend all of our builders use performance path because by nature, prescriptive path is ultra conservative. You're going to ask, how much does it cost to get a house modeled? If you send us a set of plans, if it's a one-off, we look at the size of the plans, or the size of the house and the complexity of the house, and it's typically $250 to $500 per house. Now, if you're building the same house time and time again, you don't have to model them every time. You model them once. And so that gives you a sense. And if you send in a whole whack of plans and say, here, I want you to do 20, and they're all very similar, then the cost will go down. But to have an energy model done on a set of plans It's, 3 to 4 hours of work, I would say, for somebody to do. Plus there's liability associated with it, reports to write and so on. So they're typically charging in that $250 to $500 range is where we're headed. And then I would say to you, that's energy modeling software. Now we get to rating systems. That is, if you wanted to know one house versus the next, your house versus a house built last year, your house versus the house being built across the street, there are two common rating systems. The first on the left is the EnerGuide rating system, developed in 2003 by the federal government for houses. You've all seen EnerGuide ratings on appliances and so on. Well, now there's an EnerGuide rating for houses. On the right-hand side is the energy HERS index that's used in the United States. It's the most commonly used energy rating program in the US. There are others, but it's commonly used. It's an index, and let me try to show you or talk about the differences as we go through this. Both of these use very similar algorithms that simulate energy performance, and they have this rating system that allows the comparison of the energy performance. The one on the left-hand side, EnerGuide, the lower the number, the better. It's actually in gigajoules. It'll tell you the number of gigajoules of energy that your house is predicted to use. The one on the right is an index. Again, the lower the number, the better, but it doesn't tell you actual energy use. It tells you an index, a comparative index of how well your house is doing. These rating systems are both used by code. So this software rating system is recognized in the National Building Code of Canada. The HERS index is recognized in the International Energy Codes in the United States. And so I thought I'd start with the HERS rating, just so we have a sense. So as I said to you, simulation software that creates a rating, lots of software programs out there. This package is recognized in the Ontario Building Code, so could use, not yet compliant with the National Building Code. And what happens is builders offer upgrades that improve the performance. The rating system includes blower door testing, duct leakage testing, drywall inspection. In Canada, there is an organization that is delivering the rating system. They're centered in Toronto. Fairly narrow scope, I would say, in terms of great company, but I know they don't travel across the country. They would be happy to talk to somebody if they want to do it. The key to the HERS index is to understand this. It is an index. That is, it's comparing a house to itself. It's based on, the scale is based on 0 meaning zero purchased energy, and 100 meaning a house that was built to the 2006 International Energy Conservation Code of the US. And what this means to you is a 10,000 square foot house could achieve a HERS score of 65, and a 1,000 square foot house could achieve a HERS score of 65. It's an index. It's basically saying that 10,000 square foot house at HERS 65 is 35% better than the same house built in 2006. That's what it means. It's showing you, relatively speaking, how well you did. And if you took a house at 65 and took it down to, say 35, you would say, oh, I cut the energy use of that house in half. It's an index, so it doesn't tell you actual energy use. Hopefully that's clear enough for you. They find it useful in the US because they don't want big houses to necessarily be compared to small houses. So they like the idea that everybody can show, hey, in a 10,000 square foot house, I made some nice gains, cut my energy use in half, even though I know I still use way more energy than a smaller house. But that's the way that system works. The EnerGuide system is a little different. It's like an EnerGuide rating on appliances. It's been in existing homes since 2003, and over 1 million houses have been rated. Again, simulation software, builder offer upgrades, a blower door test, final inspection are done on every home, and an EnerGuide label is ultimately issued. And again, on the left-hand side, you'll notice 0 base scale, 0 meaning 0 purchased energy. And it's essentially saying to you, based on the house you gave me and the plans you gave me, this particular house is using 144 gigajoules of energy. And so a large house is going to use more, a small house is going to use less. And the goal is, of course, everybody should get their houses down to zero. The cost to run this is in the $400 to $800 range. A lot of that has to do with site visits. And you're going to say in northern communities, what's the capacity? Clearly, somebody from my market isn't going to travel up to northern Ontario necessarily. So the cost really comes down to, is there somebody local who can do that blower door testing? So let's imagine again, the energy model only costs $250. To get an actual rating is $400 to $800. Pretty okay with that? Simulated model can be done from anywhere. I can do a set of plans for China, for heaven's sakes, from my office. But to actually do a rating, I have to go to the house and test and make sure that things were done correctly. That's the difference between an energy model and an energy rating. Energy modeling can be done for code. There's no requirement to do this rating for code. It's an absolute option. Building code you can do without any energy rating at all. You can just do an energy model if you want. So there you have it. And when we think of this EnerGuide metric, it is based on a gigajoule. And you'd say, why did they choose gigajoules? Well, it was kind of to appease the two different utility bases. That is, electricity is done in kilowatt hours. The natural gas folks would say, well, we sell in cubic meters of gas. They wanted to bring together one metric. So gigajoules is simply a metric version. And you'll see here 1 gigajoule equals 278 kilowatt hours of energy. 1 gigajoule is equal to roughly 1 million BTUs of heat from natural gas. So it's an equivalency. And the EnerGuide rating includes these 6 items: energy for heating and cooling, for ventilation, for lights and appliances, for normal hot water, and ultimately energy produced on site. Notice the last of the last 2 of the last 3. Energy for normal lights and appliances, energy for normal hot water. When you're doing an EnerGuide rating, you assume 4 people living in the house. You assume 4 people living in the house and taking normal showers and watching TV and running appliances in normal ways. So you might say, well, that doesn't match. But remember, this is a rating. It's trying to compare houses to another house across the country. So that's why they're using this normal lights and appliances mode. You can, in the software, you can change and model based on higher occupancy or lower occupancy. But when you're doing the rating, you always assume what are called default base loads. So I'll give you a sense of what that is. I thought I'd go back to the HERS score. There's a little animation that plays here. With any luck? Yep, little animation. This is the US HERS rating, benchmarked at 2006 code. The US program is trying to drive everybody to zero energy by 2030. And basically their codes have shown a nice progression of roughly 15% improvement every 3 years in the International Conservation Code. And in the HERS index, by the time you get to roughly HERS 40 to 45, that's what we would call zero energy ready. That is, no amount of insulation, no matter how many panes of glass you've got, by the time you get to HERS 40, the only thing that's left to do is to either take shorter showers or turn off the TV or to generate with electricity. So on the HERS index, HERS 40 is about as low as you can go. I'm lying a little bit. I built a house that got down to HERS 31 without putting on solar because I put in extreme amounts of insulation. But from a practicality standpoint, by the time you get to HERS 40, you're really stuck and you end up putting solar panels on the house to get it down to zero. Why? Because the HERS index includes lights, appliances, hot water, in which case, it's hard to make those more efficient. So I just want to give you a sense of that. We always joke that that's what a zero energy house looks like. That's, of course, not what we'd like to see you build. We'd like to see you build better enclosures, especially in northern climates, because obviously we're not generating much electricity here when it's full of snow and dark. But I thought I'd give you a little sense of how an energy model is done. So there's a set of plans for a house. This is actually an RTM, so you'll notice the dimensions so that it's easier to move. And when you do an energy model, An energy advisor like myself simply takes the sets of plans, click, click, click with the computer to get the ceiling areas, the wall areas, the window areas, the foundation areas. We put in the insulation levels, we put in the mechanical specs. And you can imagine on a computer, I'm entering this. I'll show you what the screens look like in a second. And it takes you to do the energy model hour, hour and a half for this kind of house. Plus, then there's some fiddling around in terms of reporting. That's why I said it's 2 to 3 hours worth of work to get that done. And we use the program called Hot 2000, in this case, Hot 2000. You'll notice on the left-hand side, you're basically building the house on the screen. You put in the ceiling levels, the wall areas, the crawl space, and so on. And you'll also notice a bunch of defaults. What temperature is the house at? What's the base loads in terms of number of appliances? Is there any generation? And then you put in things like, what are you expecting the air tightness to be in? What ventilation system you use? What heating cooling system are you using? What hot water? And so on. And then on the right-hand side, there's a whole bunch of screens that allow you to choose where you're located, what weather file you want to go to, what fuel you want to use, whether you're in imperial or in metric, and so on. And in this context, the most important, of course, is the climate zone. Because obviously the climate has big difference as to the performance of the house. But things like fuel choice, expected air tightness, expected occupancy zone, and so on. So you do that energy model for that house. And I just wanted to show you the details. So when I get to walls, I get to make up a wall down at the bottom right there. You'll notice I can choose a 2x6 wall. These are all drop-down menus. I can go from 2x4 to 2x10. I can choose the spacings of the studs, 16-inch, 24-inch center. I can choose the type of insulation. There's over 30 different types of insulation I can choose for the wall cavity. And if I'm using insulated right at the bottom of that piece there, the insulation that I'm using in the outside, I can even choose a different interior finishings and different exterior finishings. And so each wall is done differently. And so that means there's tremendous flexibility, depending on your communities, whether their preferred methods of build, lots of flexibility to model that. And that's why I'm saying to you, performance path using these energy models, you'll find very useful. Let's say you're using insulated concrete forms, or you're using SIP panels, or perhaps you're bringing in panels from somewhere else to erect, or perhaps you have a local source of an insulation product that you might want to use. You have the flexibility to enter that into this model. So this is the energy model that's done. And then once you've done the energy model, it spits out a report. And what we talk about doing is optimizing the options. This is our company, this Building Knowledge, we do this optimization report. And you'll notice top middle, I guess, there's a column that says, here's the national building code requirements, minimums, R50 in the ceiling, R22 in the walls. And on the right-hand side is, here's what you've chosen to build. And so we've optimized. This particular builder was trying to get to, or he's actually, as a modular builder, he was trying to offer close to net zero construction. And so look at the bottom third row up. The energy consumption of the house is 64 gigajoules when built to code, and 49 gigajoules when built to those specifications. So instead of, for example, you'll notice the change. Instead of R50, they put R60 in the ceiling. Instead of R28 in the cathedrals, R31. Instead of an R22 wall, they did a 2x6 wall with R22 plus 2-inch of insulation, R10 on the outside, and so on down the list. They went from double glazed windows to triple glazed windows. They didn't take any credit for air tightness, because this is a builder who is shipping this product and he doesn't know how airtight it ends up. And so you'll notice a nice reduction from 64 gigajoules down to 49 gigajoules, a 15 gigajoule change. In other words, about a 25% improvement in performance, as that bottom right row would say, or cell would say, 23% improvement in the overall performance of the house by making those changes. And that's really the value of energy modeling. Which of those was most cost effective? And I'll cover that here in a second to show you which of those might have been the best bang for buck. So that's the optimizing of options. I should stop there quickly. Any questions? John or others? John or Rudy?
Yes, there are. Actually, Albert's got a good question. He said, does the modeling take into account climate change?
It does not take into account climate change. Here's what it does use, Albert. It uses, they just updated the weather data, weather files. So I'll take my answer back. It does take into climate change, but on a 5-year rolling average. That is, they take the 30 years of weather data, roll it over every 5 years. So indeed, they just changed the weather data files. This is the third time in my experience. And magically, Toronto has gotten warmer, for example. I happen to know because Toronto is, a climate zone that I use all the time. And the climate in Toronto has gotten warmer. Now, it's not predicting out future, but it is taking into account the rolling average of weather and what that's doing. Hopefully that answers. It's they update weather files on a regular basis. They just added a whole bunch of new weather files, which is quite helpful as well, because at one time for all of Ontario there was only 6 different weather files, or 7 or 8. Now there's dozens and dozens in Ontario, for example. So it allows you to be more specific about where you're building. Any other questions?
I have one, and I think you're probably going to answer to the next question. So this modular home builder, he's got to decide at the end, is it worth the additional cost, which he'll pass on to the client or customer to make those changes?
Exactly.
Right? That's the bottom line, correct?
Yep.
Okay.
Exactly.
Okay. Yeah.
And for example, in Hot 2000, you can put in the cost of fuel. If you're paying $1.50 a liter for propane, we can put that in. If you're paying 30 cents a kilowatt hour for diesel generated electricity, you can put that in for any number of places. And so that's exactly what this builder does. Is he said, well, I'm shipping it up to whatever community. He'll ask them their energy prices, and he'll ask us to put those energy prices into the energy model. And again, remember, it's not perfect. It may not match exactly what the energy use would be in that community, but it would give a comparative sense of, oh, when I did this, I was able to show reduction of this amount in terms of expected energy use. Good. So I'll continue on unless there's another question. So I took that house and I did it for various locations. And I went way out to the West Coast and picked Herbert Island, which is just off the northern tip of Vancouver Island. Went to Battleford, Saskatchewan, Pond Inlet, and Nunavut, Saugeen Shores, where my cottage happens to be in Ontario, and Bathurst, New Brunswick, where my wife was from. I kind of had a connection to each of those, so I thought I would put those in. And what I would have you concentrate on is the middle column. The total estimated annual energy use in gigajoules for this house, heating and domestic hot water, is the same house, 20 gigajoules in Herbert, BC, or Herbert Island, 32 in Battleford, 59 in Nunavut, and so on. Notice the big difference between, of course, Herbert Island and Nunavut. But perhaps more importantly, now go to the left. Of that 20 gigajoules, only 1.3 of those gigajoules was used for heating. In other words, the other 18 was for hot water. Remember I said normal hot water use? We don't know how much energy people are going to use, so we assume 4 people showering and cleaning on a normal basis. And it turns out when this house, the one that this builder has suggested, there's actually very little energy used now in Herbert Island to heat that house. And yet in Pond Inlet, still lots of energy being used. But you'll notice in all cases, except for Nunavut, the hot water use is now bigger than the heating use. When you get to more and more efficient buildings, the impact of the hot water is actually bigger than the impact of the space heating loads. In other words, we kind of been there, done that, which says, is there a better way to heat hot water as we get closer and closer to net zero? Look also on the right-hand side. The software is assuming 4 people, lights and appliances, watching TV, cooking, refrigerator, and so on. And the base loads basically don't change across the country. And notice that base loads and hot water loads are way bigger than the actual rest of the energy use. That's what we need to understand as we get further and further into energy efficiency. Now, mind you, this was an energy efficient house, right? Triple glazed, 2 inches foam on the outside. We've already done some pretty nice stuff to this house, but now this house across the country, and you can imagine in Herbert Island, if somebody said, hey, I want to make this house even more efficient, you'd say, well, you better find yourself a more efficient water heater, a more efficient refrigerator, more efficient lighting, because no sense putting more insulation in that building. You're pretty much been there, done that. Even in Ontario, the Saugeen Shores, you're only at 4 gigajoules left. What should I be doing? Better water heaters, so on and so on. So obviously you need to get the enclosure right first, but then thinking about where this goes. And this is hopefully where you'd say, I get it. This energy model could really help communities understand the bills, the energy bills, and where the energy is going. It's could be pretty useful to you.
So for the total heat and hot water, would you, for example, go on to a water on demand type of thing?
Yeah,
Or
so
look at efficiencies in water tanks, right?
right, exactly. So how far can you get? Well, you can get to heat pump water heaters, for example. So a heat pump water heater, electric water heater, many of your communities would use electric water heaters. They are roughly 100% efficient, 97% efficient. For every dollar of electricity you buy, you get $1 worth of heat. But a heat pump water heater, they are 300% efficient. For every dollar of electricity you buy, you get $3 worth of heat. Now, the problem with heat pump water heaters is they are cooling the house while they're heating the hot water. Well, does that make any sense in Pond Inlet? And the answer is no. But in Southern Ontario, in Saugeen Shores, for example, when a good part of the year you want to air condition the house anyway, the heat pump water heater becomes a nice a cooling system for your house, and at the same time heating your hot water. So all summer, you're getting a really nice benefit out of that heat pump water heater. What is coming is air to water heat pumps. So an actual outside air source heat pump that then heats hot water. So we do need to take a stab at and get better efficiency out of our water heaters. But in some communities, you might still have propane fired water heaters or oil fired water heaters. Well, they're only 60 to 70% efficient. By all means, change those to direct vent, tankless water heaters. They would be a much better choice. So hopefully that's helping a little bit. Unless there's questions, I'll keep going. So that annual, and then, so that's the energy modeling side and energy rating, HERS, EnerGuide. Now we move towards energy labeling programs. These aren't necessarily recognized by code. These aren't rating systems in themselves. They're labeling programs that have very specific pass-fail requirements. So an EnerGuide rating, 144 gigajoules, 32 gigajoules, 0 gigajoules. There's no pass-fail. The number is what it is. Same with a HERS index, 6500, whatever. These programs would say, I want you to do the energy rating, and then I'm going to tell you what I want the number to be. So, for example, in the R2000 program, you have to show half the amount of energy use as a standard code build house. So if a code build house is 100 gigajoules, you have to show up 50 gigajoules. There's an actual pass fail to these programs that you want to get to. The net zero program, you have to show that you are 0 gigajoules in order to get there. And all of these programs have very specific registration and validation procedures. Every one of them includes at least one site visit to make sure that whatever was built met these requirements, tested performance. So the question always becomes, what's the value in these labels? And I would say it's a quality assurance process, right? It gets you an actual quality assurance. You know, I have homeowners who would say to me, how do I know they're a good builder? Make them build Energy Star, make them build R2000. And therefore, you know that somebody separate is coming to have a look at the energy performance of the building. So hopefully you get that distinction. You have energy ratings, HERS or EnerGuide, which just give you a number. Then there's actual energy labeling programs that have very clear pass-fail requirements. Any questions at that point? No? That's fine. We'll keep going then. And I'll just go over, highlight a few of these. R2000 is the oldest energy efficiency program in North America. It was developed in 1982 based on $75 million worth of cold weather housing. It was really designed as a demonstration and transfer technology program. There's been lots of R2000 houses built in First Nations communities across the country. They've done very well. I personally have seen many of them, have certified many of them myself. Thousands of builders were trained under this program. It is exported around the world. It uses Hot 2000. It's now become basically the entry point for net zero homes. So not a lot of R2000 houses being built at this point. Still quite a few in New Brunswick and so on. And typically to go through that process is $800 to $1,500, notwithstanding travel and so on into remote communities. So there is a cost to the registration. What is nice is there's a permanent registry kept of R2000 houses. You can go look it up and see whether your house was R2000 qualified or not. The Energy Star program actually grew out of the R2000 program. The R2000 program was considered to be, I'm going to say, too complicated, too complex. So they developed a simpler program. It was based on the U.S. program. In the U.S., there's been over 2 million Energy Star labeled houses. In Canada, there's been over 100,000. It is clearly the largest, most popular energy efficiency program in North America and in Canada. It's based on the same science as R2000, but it has this extra quality assurance, or I would say a little relaxed quality assurance procedure. And its promise is it'll always be 20% better than the prevailing code. So whatever the code is in Ontario or Saskatchewan, if you build an Energy Star house, you're getting a house that's 20% less energy use is what you need to know about that program. Fairly simple, fairly straightforward. Here it is here. You work through a licensed service organization. You work through a licensed advisor like myself, very defined, a well-defined quality assurance process. You get this label. And typically the cost is in the $500 to $800 per house to have a label produced on a one-off situation. Again, if you're doing dozens of houses, the cost would come down. And it's a pretty simple, useful label saying that I'm better than code by about 20%. And then I mentioned that the Zero Energy program, and I mentioned this one last time, so I won't spend too much time on it. This is a program that was defined by Canadian Home Builders Association. And its goal is to make houses zero energy, get houses to the point where they're going to use, on average, over the course of the year, 0 gigajoules. So you're on a zero energy house, you're putting solar panels on the roof, and you're understanding that in Nunavut, I don't get a lot of solar in the winter, but I got a whole bunch of solar in the summer. So as long as what I make in the summer makes up for what I used in the winter, that would be called a zero energy home. And that's a pretty straightforward program. The Net Zero Ready is everything but the solar panels. So you could say, I'm going to build a house as good as I can, and then someday later put on the solar panels. But when I do put on the solar panels, I would be achieving a zero energy home. And the base requirements, you use Hot 2000, you simulate the energy use. You have to be at least 33% better than code on the enclosure itself. You got to meet an air tightness level of 1.5 or less, and then a very comprehensive quality control. It's about $800 to $1,200 per house, again, notwithstanding travel cost. But typically in Southern Ontario, if somebody's doing a net zero house, we were charging $800 to $1,200 per house to do the verification, certification, labeling, testing, so on and so on. So you get a sense of that. But I thought I'd just spend unless there's any questions, the last 15 minutes on giving you examples of what moves the bar. That is, what makes that number of gigajoules go down in Pond Inlet or in Herbert Island. Let's figure that out. And it is all based on science. This is the value of the energy model. If you saw this energy model and you saw that only 5% of the energy goes to heat loss through the attics, but 30% to where it went to air leakage, you would say, well, I'm not going to spend any more time insulating the attic. Why would I go to R70? Doesn't make any sense. Why wouldn't I make my house tighter? And this is, to my mind, really important for First Nations communities to understand that the single biggest bang for buck in your houses would be to make them tighter, old or new, to make them tighter. So better air tightness, better foundations, better walls, better windows. And I thought I'll give you an example. And so in order to get to net zero, what you want to think about is doing a better enclosure and better mechanicals, and then adding solar panels. And for your interest, almost everywhere in Canada, almost everywhere except St. John's and Newfoundland because it's foggy all the time, one solar panel generates over the course of the year about 1 gigajoule of energy. Even in, I haven't checked in Pond Inlet, mind you, but because you have 24 hours of daylight in the summer and none in the winter, you would still, over the course of the year, have generated roughly a gigajoule. Why? Because you have lots of clear skies. I'm assuming Pond Inlet has clear skies. I don't know its particular climate, but this number holds up in many locations in Canada. It varies a little bit. And obviously the northern climates, you're generating it all in the summer and trying to recoup it in the winter. You go, what do I do? Store it? There's no way to store that amount of electricity in batteries. You'd have to store it some other mechanism, or you'd have to use the grid as your storage system in northern climates. But I thought I'd give you a little sense, for example, in terms of air tightness. If you go from 3 air changes per hour, which is kind of the assumed code, and you go to 1 air change per hour, whether you're using the HERS software or HOT 2000, you'll notice the HERS software gives you a slightly different score than the HOT 2000, but comparatively, they give you roughly the same change, roughly 11 to 12 gigajoules. Just getting a house from 3 down to 1 saves you 11 gigajoules. And you just heard me say 1 gigajoule is a 1 solar panel. So you'd be able to say, okay, I'll go to 1.5. I should have, sorry, my apologies. I labeled this wrong. But if you went to 1.5, it's saving roughly 9 gigajoules, which means it's saving 9 solar panels. So the first most important thing that moves the bar of gigajoules or energy is always air tightness. Now you're going to say, if I've already got that fixed, what next? What do I do next? And then we would say, let's look at windows. This is for kind of middle of the country, Halifax, Montreal, Ottawa, Calgary, in that kind of middle plane of the country. Here's what windows will do. If you take standard code compliant double glazed low E glass and go to triples, even one layer of low E, you're saving roughly 4 gigajoules, 4 to 6 gigajoules. So triple glazed windows in the center of the country saves you 4 to 6. Clearly in Pond Inlet, triple glazed are going to save you more because it's going to be a bigger bang for buck in far northern climates. But basically triples are somewhere between 4 and 6 solar panels. So, okay, got to do my air tightness, got to get the windows done. Well, what do we do next? Well, if I add 2-inch of insulated sheathing to the outside of a house, again, middle of the country, again, another 5 to 6 gigajoules. And you would say, well, why did you do windows first before you did the wall? Well, it depends, right? If you have in Southern Ontario, if you have a 2-story house with 25 windows in it, that could be pretty expensive to do the windows. But in your houses, modest number of windows, single story for the most part, modest number of windows, you're going to find, boy, adding triple glazed windows is 1 phone call to 1 supplier. Adding foam to the outside of the house or insulated sheathing doesn't have to be foam. Well, I got to change my wall dimensions, which may change my foundation dimensions. I got to change my window build outs. Wall insulation typically is more expensive to do than a window change, or more difficult to do. So this is what we think about, is how easy is it to do? Air tightness is relatively inexpensive, some caulk, some tape, some foam. Yes, I got to test the house, so I'd have to have a blower door access. Windows are one phone call, so that's really easy to do. Windows have the added benefit in northern communities of reducing condensation on windows because the windows are warmer. So if you have high occupancy rates, you go, I like the triple glazed windows just for their condensation resistance and less mold more than almost anything else. So air tightness, windows, walls are all the kinds of decisions that you start thinking about making. And then ultimately, you're going to end up, especially in communities, if you definitely want to get to net zero, and especially if you're using solar, you're going to get the heat pumps. Now, many of your communities, you're going to need cold climate heat pumps far north, but nonetheless, heat pumps, because of their efficiency, electric space heater is 100% efficient. This heat pump is 300% efficient. For every dollar of electricity you buy, you get $3 worth of heat. Now, in northern communities, you're going to say, do I have access to refrigeration mechanics? Am I going to be able to service these units? Not as difficult, obviously, in more southern locations where there is access to equipment and so on. So that's a decision. But notice how many gigajoules it saved. And you're going to, why didn't you do it first? Here's why. You don't want to have to oversize the heat pump. You'd first like to do your air tightness, then your windows, then your walls. Now the heat pump gets smaller. If I don't do the windows first, the windows and air tightness, I end up having to put in a 5-ton heat pump. Whereas if I've done the windows, the walls, the air tightness, now I'll maybe only need a 2-ton heat pump. So you always want to do the enclosure elements first, then come back and do the heat pump. But really hard to deny the use of a heat pump. I showed you this slide before, but in an Ontario context, that is, that Saugeen Shores, our 60 in the ceiling, our 30 walls, our 30 basements, our 10 to our 15 under the slab, and the cost is in that $10,000 to $15,000 range. Of course, you guys have to make the decision at your community level. What's the price of fuel? What's the payback? All of those good conversations. And I would say to you, just to finish up, I'm advocating that you use performance modeling if you're building new houses or if you're making assessments on what to do in old houses. I would say use HOT 2000. It's the most common software. Use a registered energy advisor or become one yourself. I'd encourage you to do it. It's not that difficult. Obviously, you got to choose knowledgeable trades and train your trades. And I would say this integrated design process, that is, let us do the energy model. Let us help you define the specs for the equipment that you want to use and figure out these process issues. What's easier? What's quicker? Triple glazed windows, foam on the walls. How do we get that done is where we'd like to get to. Won't do that one. And then, so just to finish off, the most commonly used software in Canada is HOT 2000. It's free. You can download it now. To really learn how to use it, it's 2 to 3 days of training. The most popular program from energy perspective has been Energy Star. It may not be applicable in remote communities, but it has been a very popular program. Habitat for Humanity uses it quite regularly. The EnerGuide performance path makes sense for First Nations, and others can work too. There's not to say that others can't work, but again, I'm making this pitch that performance path is the way to go. And of course, the goal is the same. We're driving down to zero energy and zero carbon. And the same basic improvements work in all climate zones. That is, you want to use, well, I guess in Herbert Island, you probably don't need triple glazed windows out on Herbert Island, but everywhere else you want triples. Everywhere else you want air tightness. Everywhere else you want insulated sheeting on the walls. It becomes a question of how much. In Pond Inlet, you're going to want more than R10 on the outside of the wall. You're going to want R20 or R30 on the outside of the wall, which of course is much more difficult to build, and we need different systems. So it will vary by community, but the same basic concepts. Get your air tightness done. That can be done in Pond Inlet just as well as it can be done in Herbert Island. Get that done. And then think about windows and then about walls and so on. And, pretty much we're still at triples in northern climates. Their quad pane windows are available and might be worthwhile in Pond Inlet. They're not as available as triples. So that's about what I had. Are there any questions?
We had a one question. Would solar panel be practical to heat water?
It's a great question. Solar thermal. And I would have said, in fact, you can see it on this house. This happens to be my house. Look at the solar shingles, which I wouldn't necessarily recommend. Well, if they were more available, I guess I would. We all imagine someday somebody's going to build PV integrated buildings, but PV integrated into buildings. But that little panel on the right-hand side is solar hot water. And that sucker makes a lot of hot water. In fact, it makes too much hot water. And it overheats in the summertime and it's maintenance issues. That poor little guy, it's only been on the house 6 years and it's only run 3 out of the 6 years. I can't get it maintained. Obviously, in northern, I'm in Saugeen Shores, so I have to worry about freeze up. So it's got to have glycol, and the glycol has to be changed every 3 years. 30 years ago, solar hot water was like the bomb. That's what everybody was going to use. PV was not cost effective at all. 30 years later, PV has come way further than hot water. And I wouldn't say don't use it, but I would say it requires maintenance. I would say to you, for example, your schools, your community buildings, all right, where you have maintenance folks and so on regularly looking at them, I'm good with that. But I think these are problematic. And they're only going to work part of the year. They're only going to work for you in the summer, and you can't store the hot water long enough. So I would say limited use. I'm sounding kind of down on them. The only reason I'm down on them is because they haven't figured out the maintenance.
Interesting. Harry, do you have something there? I can read you. I got to unmute you there, Harry. There you go. Harry, you got to unmute yourself there.
This is all absolutely wonderful and just marvelous to see. We deal with a consultant named Jim Nostad in Winnipeg, and he's pointed out that the cost of maintaining and heating a house over 10 years, or not 10 years, but the life of the building can be as much as 10 times the original cost. So paying attention to insulation and things at the early stage of the game can save you big bucks down the road.
Absolutely. No argument.
Yeah.
Totally
So anyway,
agree.
I think the problem I have is that I'm promoting lots of air changes to try to cut down on the mold buildup. we gotta way to somehow balance this.
Okay, I'm okay with that. Here's my point. You don't want that air change through wall cavities. You don't want it through holes in electrical outlets, and that cause you more problems. I totally agree. You need ventilation, but you don't want natural leakage. So you build the enclosure tight, and then you put in ventilation. And that can be windows, or that can be fans, or that can be HRVs or ERVs. And I know far north, we're trying to work on better HRVs that work better in far north. You definitely need ventilation, just not through leaky buildings.
Absolutely great.
Thanks, Ed.
Gotta go. Just wonderful.
Thank you.
Okay. Any other questions, comments? I'm just checking here to see. Nobody here. I put out how is the program set up back east for the energy companies to buy back excess of energies? I think that varies, doesn't it?
It does vary. Well, actually, it's it used to vary quite a bit, and right now I think it's pretty standard. Most utilities will accept back what you use. That is, they'll store it for you on a rolling average up to a year. It's called net metering. So you put it in the summer, they'll hold on to it for the winter. But if you used more than you generated, then you pay for it. And if you generated more than you used, then you lose it. That is, it just goes into the grid. That will change over time, but right now most are doing a net metering.
And my neighbor did it, and I believe he figures 3-4 years he would recoup his cost.
Yeah, I think that's reasonable. I've had really good, I just saw Rudy say in BC they will buy it back. And that's fair. Some won't buy it back at the total value. They'll say, well, I'm not going to pay you top dollar for it. I'll pay you my base cost. But my opinion would be I have solar on my house and my cottage, and I would say the return on investment was excellent. It was better
Yeah.
than leaving my money in the bank. Let's put it that way.
Yeah. All right. There's no other
Great.
questions.
thank you.
Before we go, again, I want to thank Gord for his wonderful presentations. And again, if you have any follow-up questions, reach out to Gord directly. He's well respected working with our communities. That's how actually I met him through Keith. And our next webinar is in September. So we have the summer off, at least for Claude and myself, not figuring what we're doing on Mondays and Thursdays. So I want to wish everyone a safe summer, you and your families, and we will talk again webinar-wise in the fall. And please send in those surveys because those are important for us to figure out how to move on this new organization. Thanks, Gord. Thanks, everyone.
Thank you,
Stay
sir.
safe.
Take care.